Thank you very much. Hi, everyone. Good morning. How many of you were in Joe's keynote? Awesome. So basically, everybody knows what Kubernetes is, right? Good. Because if you don't, okay. Yeah, as Bjorn said, I am going to talk a bit about some open source tools that you can use to do preventive security for Kubernetes. We'll talk a little bit about some of the other aspects of security because I do work for a container security company, Aqua Security. I'm also the co-author of a little book about Kubernetes security. You can download this for free from the Aqua website, aquasec.com. So if security of Kubernetes is a concern for you, read it and then ask me questions, and hopefully it's a helpful resource. I co-wrote that with Michael Hausenblas. At the time he was at Red Hat. He's now at AWS. Yeah, all good. But I feel like I should have updated that, and I just noticed I hadn't. All right, so what I want to talk about this morning, we'll talk a bit about configuring Kubernetes with security in mind. We'll talk about some benchmarks from what's called the Center for Internet Security. And we'll talk about, as I say, some open source tools for testing your configuration. Right. So this kind of fits into a landscape of security. If you do the things that I talk about this morning, it will help you with securing Kubernetes. There are a ton of other things that you would want to do in a sort of holistic approach to security. I'm not going to talk, this is kind of an Aqua slide, which I'm not really going to talk about. I just wanted to highlight the idea of automation. Automation is key to security in this kind of DevSecOps worlds that we talk about. So if we look at a super simplified version of a CI/CD pipeline, there are things that you can do at every stage to improve the security of your applications running in your deployment. At the point where you're creating and building your software, you can be doing things like static analysis on your code to check for security flaws in the application code itself. You could be doing security testing to test for things like, are you using up-to-date ciphers and versions of TLS, that kind of thing. You could and should be doing vulnerability scanning on your container images. If you do those things, in theory, you have container images, build artifacts, if you like, that, to the best of your knowledge, don't contain security defects. Then you're going to deploy those artifacts, and a couple of things you want to do there. One is you want to make sure that you're deploying them onto hosts that are secure, and you may also have some policies around validating the artifacts before you actually deploy them. So with that in mind, you would only be running the artifacts that you expected, configured in a way that you expected. And then finally, in a kind of holistic view of security, you would also want to be detecting any kind of anomalous behavior that happens at runtime. That was like a very, very, very rapid fire view of all the things that you could be looking at along the pipeline. What I'm really going to concentrate on today is just this idea of the configuration of the hosts you're running on. I kind of feel like I might have scared you with that. That kind of makes it all seem a bit like there's a lot going on. There is a lot going on. You just have to break it down into pieces. So, host configuration. You're running Kubernetes on a set of machines or virtual machines. And you want to know that those components are kind of configured with secure configuration settings. Joe showed, some of the main components earlier this morning. That there are master node components like the API server, the scheduler, the controller manager, and the node components like the kubelet. All of these different components have settings, right? Configuration settings. And some of those configuration settings have a pretty obvious impact on security. So, for example, there are settings for allowing insecure access to the API server. That is not something you want to, like the clue is in the name, right? Insecure port access, you probably don't want to have that enabled. Some of the settings are a little bit more subtle. The overall, knowing how to set all of these settings according to best practices is quite a big, a big thing to do. To go through every single one of these possible settings and think about what the impact on security could be is a pretty big job. The default settings for these options have been improving over time. So if you compare the configuration that comes out of the box, if you use something like KubeADM to install, or any of the cloud providers' default installations, the defaults have been massively improved over the last couple of years. But you might want to be sure that you're running with those good configuration settings. So the question you might be asking yourself now is, well, how the heck do I know what these good configuration settings should be? And even if I know what they should be, how can I check whether I'm using them? And that's the first thing we're going to answer this morning. Who's heard of the Centre for Internet Security? Okay, few hands. So this is an organisation that generates these or writes these benchmarks for lots of different applications, for lots of different server components. And these benchmarks give you advice on what the configuration should be with security in mind. So rather than you having to go through every single one of the, I don't know how many dozens, hundreds of options there are in Kubernetes, the CIS has done it for you. I'm actually a co-author on the Kubernetes benchmark. There are also benchmarks for things like Docker. There are benchmarks for Linux itself, the server configuration. So this benchmark can really help give you the advice around which settings you want to worry about from a security perspective. But there are a lot of them. This is about a kind of 200-page document. And because there are so many of them, we wrote a tool called CubeBench, which is open source, that automates running the checks that are recommended in the CIS benchmark. You get different tests depending on whether you're running on a master node or a regular worker node, because there are different components running on those nodes and they have different settings. And you can run this as a container. You can build it from source and run it, or you can install it as a container. And what that's going to do is give you some output like this, telling you pass, fail, or even warning for all of the different settings the settings that are recommended in the benchmark. So that's a screenshot, but let's actually look at it running. So I have it installed on this. Let's just check that the node is up and running. I've just got a single node cluster for demonstration purposes. And we can just run KeyBench on it, which I've got pre-installed here. And there's actually, it's auto-detected that this is a master node. So it's run all the master tests. And you can see some of them have passed, some of them have failed. And then we start getting some remediation recommendations. I hope this is kind of big enough to see back there. So it will tell you how to remediate the problems that it might find. You might not necessarily want to adopt every single recommendation. There might be reasons why you don't want to follow a particular recommendation, but at least it's a good idea to know, look at it, be advised and think whether a particular test is problematic in your environment. So that was the master test, then there's some node tests, and you can also get the output in JSON format or YAML format so that you can automate the parsing of this and maybe flag up. If you run this regularly, you might want to flag up if there are any changes. There we go. So that's Cuebench. The tests themselves are written in YAML files. So if you decide that maybe one particular test doesn't apply in your environment, and maybe that's true, you could just modify the YAML really easily to skip that particular test. We try to stick very closely to the tests as defined in the CIS benchmark. Sometimes the benchmark has, bugs effectively, and we take the approach of saying, well, let's fix the benchmark and then have the Cuebench tests reflect what is in the benchmark. But you might decide you want to modify the tests individually just to cope with issues as they come up. It doesn't happen that often, but it has happened a few times, particularly because Kubernetes, it's still an evolving product, right? And things change from release to release. CIS benchmark gets updated about every 2 or 3 Kubernetes releases. So sometimes, which is really just a reflection of the work that it takes to write a new version of the CIS spec. So sometimes in between releases, there are tests that you might want to modify. Key thing is, though, that you can run this, day in, day out, in an automated way to spot if your configuration has perhaps changed from the recommendations. If you're a commercial Aqua customer, the benchmarks are actually also included in our UI, so you get like a nice UI version of that. Okay, so that's told us something about how to check your configuration matches the recommendations. Now I want to go on to talking about how that kind of affects your actual security posture. If you're running a deployment and somebody tries to attack it, what can they do? And how do those security settings affect what kind of attacks they can succeed with? We built a tool called CubeHunter to answer that kind of question. So the idea is that CubeHunter is basically penetration testing for Kubernetes. It's not doing anything that an attacker couldn't already do with kind of pre-existing tools out there. But the idea of this is to make it really easy for operators of Kubernetes to understand any potential vulnerabilities that have been found. Essentially, it's there to answer the question, how do you know whether the configuration you're running with is actually securing your cluster? Does it leave any holes open? Do I run it outside the cluster? Yes, absolutely. You can point it at, in fact, you can see in the screenshot there, you can specify an IP address or a domain name, subnet, IP range, and you're pointing it at a Kubernetes cluster. There is another option we'll come to later, but for now, you're running it as if you were an attacker outside of the cluster. Please only run it on your own clusters. Right. Okay, so I am going to run CubeHunter against so I'm running it on my laptop against my local Kubernetes cluster in my VM, which has this IP address. And what it does, it's basically looking at the ports that are commonly associated with Kubernetes and trying to see what kind of requests it can make and what happens. And as we can see, it found a few things. Again, I've had to go for a compromise between line wrapping versus font size here, so I hope it's kind of readable. I'm just going to scroll back to kind of the beginning. So it found my node, which is a master node. It found some open a kubelet API and 2 API server ports. One's on port 8080, one's on 6443. And when we get down to the vulnerabilities, we'll see that port 8080 here, this is actually the insecure port. What I've done here is I've got my Kubernetes master configured with the insecure port open, port 8080 open. And that has allowed the CubeHunter to find all sorts of interesting things, like it tried listing roles as anonymous user. It tried, it was able to do all sorts of things to get information out of the cluster. I ran it in what we call passive mode, which is the default, where it just tries to query things. It doesn't do anything that could potentially alter state. We do also have some active tests where it will try to do things like create a pod and things like that. Definitely only run that on your own clusters. Okay. So that CubeHunter is there to show you the kind of consequences of your configuration setup. You probably won't be running with your insecure port open because that has been turned off by default for many releases now. But, you might want to check. Now let's look at what happens if you kind of combine the power of these two tools together. Like Cuebench will show you the security settings. CubeHunter shows you the consequences of those settings. How can you kind of combine the two? My screenshot example has anonymous authentication on the kubelet API. That is showing a failed test from Cuebench. So that kind of gave a clue that there was a problem. And running CubeHunter with that particular setting. Oh, sorry, no, this is Cuebench telling you how to remediate that problem. I haven't got the screenshot of CubeHunter. Never mind, I shall show you a live version instead, which is much more effective. So, in what we saw here, we saw this port 8080 being open. And if I go back to the KeyBench results, where are they? Here we go. You know what, I'm just going to rerun and just run a subset of the tests so it's easier to find the one I want. And we should find here, right, these two failures about the insecure port and the insecure bind address are why I was able to access port 8080 and read things as an anonymous user. So the clue was there in the Cuebench output, and the consequences were there in the CubeHunter output. So I could change this if I find, here's the, I want to try and find the right one. Here we go, insecure port. I mean, they're all referring to the same file, but this is the file that I would need to modify. And so Joe was talking about how Kubernetes responds to changes in configuration. Kubernetes server components, everything is configured as a, it's using Kubernetes to observe changes. So I can change this configuration file and it will pick up the changes sort of on the fly. So if I can find my cursor, let me take out this comment and instead comment out this. So I'm turning off the insecure port and the insecure bind address with these changes. At least that's what I'm intending to do. And we probably have to wait for a few seconds for Kubernetes to pick up the changes to that. So if I type this really slowly, hopefully. Yeah, it's not ready yet. I have to wait for a little bit longer. Let's hope it comes up. It is going to come up. Demo gods will be with me. There we go, it's ready. Right. So my Kubernetes cluster should have picked up that configuration change. We can check with the Cuebench test and okay, so my insecure port and insecure bind address, tests are now passing. And if I try and attack it from, we're using CubeHunter on the same test. And it will still find some things, but hopefully, yes, it's found much less. So now we only have one API server port. This is 6443, that's the secure port. This at least is using HTTPS, it's secure. And we should find here, well, basically I've only got two potential issues here. The first one here, just kind of to explain what we're seeing here, this is unauthenticated access to the HTTPS port, which is arguably okay, because so long as you're using RBAC, everybody familiar with RBAC? Mostly nodding, okay. So RBAC is going to control who is allowed to do what. And the idea here is that if RBAC prevents anybody from doing anything dangerous, you can allow unauthenticated access to help with things like service discovery and health checks. So that's arguably okay. The other one that we've got here is my node is actually not patched for a particular CVE that could allow a denial of service. So that would be a flag that I need to upgrade my version of Kubernetes. But what we didn't see here was that anonymous that whole set of issues where I was able to anonymously access the server. All right. So there is one other place that is potentially, well, there are several other places from which you can be attacked. But one interesting thing that we can test for with CubeHunter is running CubeHunter from inside a pod inside your cluster. Why would we want to do that? So imagine your application code. Your application code is sitting in a pod running inside your Kubernetes cluster, doing whatever your application code should do. And what you may or may not be aware of is that by default it has access to a service account token. Your pod is running under what's called a service account. That service account is kind of an entity for RBAC. So it may have some permissions associated with that service account. And the token gets mounted into your pod, which would allow your application code to use the Kubernetes API should it need to. And what it could do with that token depends on your RBAC settings and the service account it's running under. Now, suppose your application gets compromised. Maybe you're running with some vulnerability. Maybe something like, I don't know, Heartbleed or Shell Shock or any one of the thousands of vulnerabilities that get discovered all the time. If your application is vulnerable, an attacker could potentially compromise it. Then your attacker is sitting where your application code is and can do things. Maybe your attacker could then read that token and start accessing the Kubernetes API server. What could it then do? Well, how can we test that? One thing we can do is run CubeHunter inside a pod and see what it can do with the service account token. And let me sort of demonstrate what I mean by this kind of API access. Oops. Right. So I want to be in my machine. Okay, and I have a pod running. Is this big enough, or does it need to be a bit bigger? We okay? Right. So I've got a pod just running. It's just something that has curl installed, really. And I'm going to exec into that. I can't type this morning. Exec. And I'm just going to run a shell in that pod. And I'm going to get that token from, so it's var run secrets Kubernetes service account token. So I've got a service account token here. It was automatically mounted into the pod at this kind of well-known location. Now, if I try to issue a curl request against the Kubernetes API, API v1, let's look at namespaces. So hopefully you can see down there I got a 403 error. I don't have permissions, I'm forbidden. The message actually tells us a bit about how I'm acting as an anonymous user at the moment. And that's because all I did, I just made a curl request. I didn't have anything in that curl request to identify myself. But if I do the same thing, passing in a header with authorization, bearer, so I'm going to pass in that token as a bearer token, we suddenly get a whole load more information. And in fact, what I've done there to allow this is I'm slightly cheating in that I am describe pod curl. That pod is actually running under a, where is it? Here we go. This is the thing. It's got the service account has been mounted from something called Superpower. And I've actually created a service account called Superpower, which I've given basically cluster admin privileges to. And I've run a pod with that service account, which is here. So this is my curl pod running with cluster admin privileges. Now, that's not a normal thing to do. You probably aren't doing that. But maybe somebody somewhere has created a service account with a whole load of privileges, or maybe they've granted privileges to, your regular default service account. Using CubeHunter inside a pod can test what would be possible. So rather than manually running curl commands like I was just doing, you could run CubeHunter and it can explore what is possible from inside that pod. Arguably, you'd want to do that for every service account. So, there's probably more we could do to automate that. But I think it's interesting to be aware that service accounts exist and are, mounted into made available to your application code. Okay, so CubeHunter accessing a service account token and seeing what it's able to do against the API server. Bear in mind that being able to, having full access over the API, over the Kubernetes API, is basically root. If you think of Kubernetes as a distributed operating system, cluster admin full privileges over the API server is like sudo. It's all powerful. So you don't want to give away privileges to any, just like you wouldn't normally run your application code under root, you don't want to run your application code in pods with unnecessary privileges. So the results that you get if you run CubeHunter inside a pod will depend on which service account is mounted and what the RBAC settings are for that service account. You can download those, run them from, they are open source tools, Kubebench and Kube-Hunter. And of course, there is that Kubernetes security book as well, if you want to kind of understand a bit more about the kind of background to some of these settings. I think you might find that book helpful.